Hi everyone, so we're going to talk about some basics of variables. So something you need to understand is that anytime we have a variable, a lot of times we use x, but it could be a or b or y or z, is just a placeholder for a number. So for instance, if you see something like 5x, that literally just means 5 times whatever that number is, x. And then that lets us substitute different things in for this variable, and it's basically like an open box waiting for you to put something in it. So for example, suppose we wanted to evaluate the expression 1 minus x squared divided by 2 plus x for x equals 3. That just means that anywhere that we see an x, we're going to plug in 3. So here we would get 1 minus 3 squared divided by 2 plus 3. And then we would simplify using order of operations. So we work within the parentheses first. We have 1 minus 3 gives us a negative 2. We can go ahead and do the 2 plus 3 at the bottom gives us a 5. That's because it is completely in the denominator, so it's as if there are these parentheses around it. And then negative 2 squared gives us 4, so we have 4/5. All right, now the next example is asking, is the statement true when x equals 10? So again, anywhere where we see an x, we're going to plug in the 10 that it's asking us to. So we've got 2 times 10 minus 3 is equal to 7 plus 10. And we're checking if this is true. So we're kind of have like a question mark over this right now because we're checking. So we've got 20 minus 3, and we're checking, is that equal to 7 plus 10, which is 17? 20 minus 3 gives us 17, and we get 17 is equal to 17, and that is true. 17 is equal to 17. So the answer to this would be yes. That statement is true when x is equal to 10. All right, now when we're working with variables, there are these things called like terms. And they're basically terms that have a common factor, that common factor usually being the variable. So for instance, suppose I have 5x and 3x. This really means I have 5 times x, so I have 5 x's, and I have 3 times x, or 3 x's. So if I have 5 x's and 3 x's, in total I have 8 x's, right? Treat it as if instead of x's I were saying apples. And then how this is working is it's like, suppose I had a 2 in for the x. Then I would have 5 times 2 plus 3 times 2. And 2 is a common factor. And so what I'm basically doing is I'm pulling that common factor out to right here. And then I'm adding what's remaining. All right, suppose I wanted to simplify the expression by combining like terms. So I want to make sure that I collect all of my x terms, and then I collect all of the terms that don't have an x on it. Well, at first, this might look a little tricky because we have this x minus 9 in the parentheses. But what we can do is use the distributive property to distribute this 4 into the parentheses. It's actually exactly the reversal of what we did here, right? Because this is as if we're distributing this 2 right here, and then we get back to 3 times 2 and 5 times 2. So we're basically undoing what we did in the purple. So we end up getting that this is, if I'm rewriting it, I've got 5x, which I'm just leaving alone, plus I have 4 times x, gives me a 4x. 4 times 9 gives me a 36, and I'm subtracting that. And then I have 2 like terms. I have 5x and 4x, which gives me 9x minus 36. And this would be all like terms combined. Okay, for the next example, we have, even more complicated. But again, we're going to use the distributive property. So I'm going to distribute this 1/2 to kind of get those parentheses away so that I can expand everything and start combining my like terms. So I've got 1/2 times 4, which is half of 4, which would be 2. And then minus 1/2 of 2x. Well, if I'm taking half of 2 times a number, it gives me that number. So I have minus just x. We could also write this over here. 1/2 times 2x. That's like 1/2 times 2x over 1. The 2's cancel. We get x. Okay, and then we have plus 3/2 x. So then we see that the like terms that we want to combine is a minus x plus 3/2 x. So I'm trying to combine. In front of this minus x is like a 1. So it's like I have -1 plus 3/2 x. So I need to combine the -1 plus 3/2. Well, -1 can be written as 2 over 2 negative. So I get 2 plus 1/2 x. All right, for this next example, we're evaluating this expression for some given values of the variables. So anywhere I see an x, I'm going to put a 1. Anywhere I see a y, I'm going to put a 4. So that means I have square root of x, which is 1, times y, which is 4, plus 5 times y, which is 4, minus 6 times x, which is 1, divided by y, which is 4. Now that I have all those numbers plugged in, I just go through and calculate this. So I've got square root of 4 plus 5 times 16 minus 6 over 4, which is the same as 3 over 2, which is equal to square root of 4 is 2 plus 5 times 16 is going to be 80 minus 3 over 2. And now if I want to combine everything together, I want to get everything into a common fraction. The 80 and the 2 I can combine to be 82. And then I'm going to put that into however many halves it is. So I need to find 82 times 2, which is 160 plus 4. So 164 minus 3 over 2. So we've got 161 over 2. Okay, last one. It says simplify by combining all like terms. Now this one we have two variables in. We have a's and we have b's. So what we're going to do is we're going to combine the a's and we'll combine the b's. And to start this one off, we're going to use the distributive property. Imagine that there's a 1 out here. And I'm going to distribute that minus 1. So I have 3a plus 2b. I'm subtracting 4a minus b. So what that really is doing is subtracting 4a, and I'm subtracting a minus b, which is like adding b. Now I'm set up to combine my like terms. I have 3a minus 4a, which is a negative 1a. And then I have 2b plus b, which is like plus 3b. So here would be with my like terms combined.